Hello, I'm Derek. I'm a software engineer at Syntasso, and in this video I'm going to introduce a new feature that will give you more control over your Kratix workflows. So let me start by setting up the scene. So let's talk about what is the dream platform. What is that end goal that you want when building a platform in your organization? You probably want something that looks like this, right? You want it to be fully self-serve. That means then any user of your platform can go and discover what service they are available. They can request those services if it's available for them. They fill up a form, they fill like some fields, some configuration, and they get the service that they need. And everything is as fast as it can possibly be. You are running your platform on top of Kubernetes, so there is the hope that you also want a system that is under declare and converge. That is declare and converge, right? You declare the state of the world. I want this particular set of resources should become available to be created, and when and once those resources become available, the other ones detect that and convert into a state where everything eventually is up and running. And also to make it fast, you hopefully don't want any manual intervention. So you don't want any human involved in the process of providing something as a service for your users, right? You want them to be able to go and everything is pre-approved, everything is predetermined, so they don't need to wait around on anyone to do any particular action. However, as you probably know, this is often not the reality. So the reality is that the platforms do not operate in isolation. There is usually business needs that often require a human verification, be that for compliance or business rules, or like you want more guardrails to ensure that things are not deployed in production when they shouldn't be, or deleted from production when they shouldn't be, all those kind of stuff. Often as well, sequencing matters, which means you have an order of stuff that needs to be created in that order, otherwise they're not going to work. Be that because you use the technology that you use or the tools that you have available, but it means you need to wait around for that thing to be created so you can do something else. Um, and in declare and convert systems as well, things often fail. Sometimes teams are notified when thing fails, and that's kind of brings noise into your platform as well. So you want to be able to bring those processes or those needs into your Kratix promises. And what is the story so far? So you probably, if you have a promise that you already wrote a promise that needs, for example, a manual approval, which is the example that I'm going to go through today, you have something that looks like this. Your user goes and sends that request for your promise. That request runs the workflows, and the workflows can do a series of steps, right? For example, it can notify the team on Slack or on Microsoft Teams. Then you create an approval request, which means, hey, someone needs to go and approve this particular request. This you can use Jira or GitHub Issues or ServiceNow or any other system. And then you have a check stage, right? A stage that is like, okay, is that approved? And if it isn't, right now, what you can do with Kratix is sleep. So you enter in this loop of like, check if it's approved. If it's not, sleep for a period of time. Then check it again, sleep again, check it again, sleep it again. And you keep doing that until the check is satisfied. Once the check is satisfied, you go ahead and deploy the resources. Going one step down into the stack, what happens in your platform cluster is basically you have Kratix kicking off a job, and that job will kick off a pod, and that pod will be there running potentially for weeks, right? How long does it take for you to get that approval or that other resource should be created as part of that request? Will be the time that it takes for that job to complete. So that pod will be running for hours, days, weeks. So that usually makes our platform engineers quite sad because they had that useless compute running there consuming resources, right? But you don't need to do this anymore because we are introducing workflow controls. So workflow controls are a way for you to, in your pipeline, to define what needs to happen on the next pipeline execution. So let's take a look at what that means in our approval context. So the user send the request, all the same steps go through. However, when we get to that check, we'll verify, okay, is the check approved? If it's not, you can now tell Kratix to try again. Basically try again in a minute, an hour, a day. You determine like what is the step back that Kratix can do. You can implement exponential backoffs. You can do whatever you want in here. But you basically tell Kratix, hey, try again after a period of time. Then Kratix will do that and kick off the job after that period of time for you again. Eventually, that check will pass, and then you can deploy the resources. If you go again one step down, what does that look in practice? It means that Kratix is no longer going to keep that one job there. So that job is going to run to completion, but it's going to inform Kratix, hey, I completed, however, I need you to run me again in a minute, or in a period of time. Kratix will play, okay, I'll do that, and then after that period of time has elapsed, Kratix will go and kick off a new job. And then that job can run, and once again, it can produce a workflow control file that says, try again, and then so on and so on. And that will be continuously created. Kratix will continuously create a new job until you tell it otherwise. Until you say, hey, it succeeded, or hey, it failed, it timed out, or some other action is necessary. And that hopefully will make you happy. So let's take a look at how this is actually going to work. This is a new file that we're introducing under Kratix metadata called workflow control YAML. You're already familiar with the metadata directory by now. You have the status YAML and you have the destination selectors. This is another file that you can produce in your workflows that will tell Kratix in your stages that will tell Kratix to what it needs to do with that workflow. What does that file look like? It looks something like this. It's a very simple file for now. We have only 3 fields. We have a suspend key, which is a boolean. We have a retry after, which is a duration. You have a message that is an optional message that for you to surface to your user to like what's happening here. Why is this pipeline suspended, or why we're retrying it later on. So for example, in our particular approval request, you can say, hey, try again in 60 seconds. And the message can be something like, Jenny needs to approve this. So now our user knows, okay, this is going to try this again in 60 seconds, and he knows why, the reason why. So let's take a look at what that looks like in practice. So in my cluster here, I have a few promises. Let me increase this font size here a little bit. So I have an app promise, and this app promise is configured with a stage that uses GitHub as a method of approvals. So if you go to our Kratix marketplace, if you scroll all the way to the bottom, you should see we have pipeline images here. So these are stages that you can use. And one of those stages is a manual approval workflow. What that will do is that it will go to my repository, and here you can see my repository. There is no issues over there, but it will create an issue on the back of that request, and I can decide if I close the issue or not, if that request is approved or not. So let's see what it looks in practice. So I'm going to send a resource request for this. That is this one over here. So if I do resource request, you should see that I have a few fields. These are my API. So I'm just going to go ahead and apply that resource request. Cool. So what Kratix will do is, as you expect, kick off the pipeline. So this pipeline is going to run, and you can see it will complete. However, if I describe my app right now, if I get my app, you should see that it's waiting for approval on this issue. And if I describe, you should see that it's saying, okay, my pipeline is suspended, and the reason is that it's waiting on approval. This one, it tried once, and the next retry will be in a few seconds, in 30 seconds or so. Okay, so if I take a look at my issues repo, I should see a new issue here that represents the approval gate. But also interesting, if I take a look at Kratix, you should see that it's actually kicking off a new pipeline. So remember when I said that this Kratix will run the job every few seconds? So that's exactly what Kratix is doing here. So you can see that it run, and then we're saying retry after 30 seconds or so. Kratix will pick up that particular retry after a number, and will execute it again after that period of time. So you can wait a little bit more. You should be able to see a new pipeline coming up in a few seconds. So here you go, the pipeline is going and doing the checks, and it's going to verify, okay, has it been approved? It hasn't. We'll try again in a period of time. So you can see that my application here is still marked as waiting for approval. So let's go ahead and approve it. So to approve, all you need to do is close this issue, because that's what the stage looks like. And now what Kratix will do, let's do like this, is re-execute the pipeline again after that period of time, right? So once again, the pipeline will come up, and this should happen in a second now. And you can see that pipeline is coming up in here. But now it's going to verify, oh, that issue is closed. That means that my request is approved. So it will go ahead and do the rest of the stuff that it needs to deploy the application. So if I take a look at this is using a compound promise, so it's using the deployment promise, you can see that it's already kicked off the pipeline for that promise, which means that the request was approved and went through. And then in a few seconds, we should see the application coming up in my destination cluster, right? And if I take a look at what's the status of my application right now, I should see that the message has changed and is now saying my application is now available. So that's the workflow. That's how the new wait features is going to be used. We have docs for it. Take a look at it. But if you are paying a lot of attention, you should see there is a suspend field as well in that workflow control file. And what does that mean? Not everything can be pulled. So we know that you have systems in your organization that sometimes someone needs to do something manually, right? Or is in a system that is not necessarily embedded or integrated with your platform yet. So you have the option of Kratix just suspend, just don't fail, but also don't run it again. And I will tell you when you need to run. If that workflow outputs that file with suspend true, what Kratix will do is label the resource with that particular label, kratix.io/workflow-suspended. We'll set it to true, and then it will just wait. Whenever that label is removed, Kratix will go and run the workflow again, which allows you to control and interact with other systems. So for example, you could create the issue and then suspend it, and then whenever someone closes the issue, you have a GitHub action or an automation that runs on the back of it that goes and removes that label. So your pipeline is not even coming up again to check. It's being told, Kratix is being told when to resume the execution. So that's a new feature. That's all I had for today. As always, we're curious to hear your feedback, what your thoughts are on this particular feature, and that should be available to you in the next version of Ski, and also should be available on the open source Kratix. So yeah, thank you very much.